Alright, class, this is Mr. Walker here, coming back at you with the second part of this page. Now, we went through how to go through and factor in the previous section. That knowledge is going to come into play right now as we look at non-perfect squares. So, because you guys obviously don't have the capability to type out the square root symbol, I got all of these set up right here for you. If you ever need to go back and fix anything, just type out undo. So, here's what we're going to be doing. For the first part, we are going to be trying to simplify this square root right here. So this is the square root of 32. I know the square root of 32 is a non-perfect square because when I go through and put the square root of 32 in the calculator, I end up getting 5.65, so on and so forth. That's kind of messy. We don't exactly want to deal with this every single time. We want to do some math with the square root of 32. So, what we're going to do is we are going to go through and break this up using some factoring so that we can manipulate this. So, how does it work? What's our process for this? Everything has a process. So, first off, we are going to find the factors of the radicand that are perfect squares. So we're looking for the groups of numbers that multiply to give us 32, and we're looking for which one of these have perfect squares. So there's a couple different numbers that we know multiply to give us 32. Let's take a look at one. We know 1 and 32 gives us 32. We also know, more commonly, 4 and 8 gives us 32. So one of these groups does not have a perfect square, one of them does. See, both of these are non-perfect, so we don't want this. We want to list out the numbers that do have perfect squares. So this is one of our groups right here. Now, another group we have is also 16 times 2, which gives us 32. Both of these are numbers with perfect squares. We got 4, the square root of 4 is 2, the square root of 16 is 4. So both of these work. So, to the side, let's go through, let's write those both down. So I got 16 and 2, and I got 4 and 8. All right. Next, I am going to choose the largest perfect square factor, and I'm going to use it to rewrite the radicand as a product of that perfect square and another factor. So let me go through, let me just bring this down because we're going to need a little more space. Okay, there we go. Bong, bong, bam. All right. So here's what we're going to do. 32 can be written in another way. We can obviously write this as what two things multiply to give us 32. Now we see that over here. So we can write it as either 16 and 2 or 4 and 8. What I want you to do is pick the larger of the two perfect squares that multiply to give us 32. So you see I went through, I bold that. I'm going to go through and underline that just so we know. So we're going to pick 16 times 2. And we are going to replace in the radical those two numbers with that. So we got 16 here, and over here we got 2. Now this is the same thing as 32. Now what I'm going to do is I'm going to separate both of these two into two separate square roots, because since both of these are being inside of this parenthesis, that means both of them are being taken the square root of. So I'm going to take 16 here, and I'm going to write it in this parenthesis. And that's going to make it separate from the 2 that is in the other one. Now that I'm here, what I'm going to do is my very last step. I am going to take the square root of the perfect square and leave the other non-perfect square in the radical. So what this means is there's one of these numbers I can take the square root of, that's 16. So I go through and take it. The square root of 16, we know, is 4. Now over here to the right, we know that we can't take the square root of 2. So since we can't, we're going to leave it as just the square root of 2. So both of these are equal to what we had at the beginning, the square root of 32. So let's go through and let's check that out. All right, so let's back it up. We got the square root of 32 is 5.65, so on and so forth. Now, if I wanted to double check this, I need to see if 4 times the square root of 2 gives us this same decimal. If it does, that means that this is a easier way of us writing this out. Now, this is going to come into play when we deal with some operations with radicals in the next part of the unit. So, you know, we're going to practice out a little bit of this. But before we go, let's just make sure we check. 4, and then we're going to write the square root of 2. Since both of these are next to each other like this means that they're both being multiplied by each other. So this gives us the same exact decimal that we have here. That means that this is our final answer. So we're going to go through that process a couple times, okay? Now coming down here, some of these are perfect, some of them are prime, some of them are going to involve us doing this process a couple times. So let's look at a couple of examples. We're going to go through